Okay, guys, data flow. This is the last part of chapter 2. It may look like um, not that familiar to you because it's been a long time since we lectured this. It was before spring break, and it's been a while. So it looks not familiar to you, go ahead, go to the textbook, this section called data flow on chapter 2 and have a refresh. In this small section, we have several things you need to know. First, yarn, the third component of Hadoop system. Here, we're not going to touch all the details of yarn, but in general, we need to know yarn is a resource management system, and your MapReduce application, when Hadoop runs it, Hadoop using multiple mapper task and reducer task to run your application, and those tasks will be created and managed by a subsystem of Hadoop. Is called yarn. So yarn, again, resource management system. All tasks runs on nodes. The nodes is the concept. We call the computers in a Hadoop cluster. Physically, your Hadoop cluster consisting of multiple PCs. And those PCs will be all managed by yarn system in terms of managing resources, okay? And each computer, we call it node, okay? Node. And the yarn gonna try to create a mapper task, for example, and schedule the mapper task onto one node. And there's a chances that the node failed running your map task for various reasons. If that happens, you should know Hadoop, specifically the yarn system, is going to automatically reschedule the failed task to another node. Okay. The concept called split. We lectured this again for a long time. Go ahead and refer to the textbook for a refresh here. What is split? A split, first let's talk about the scenario. When a MapReduce task runs on your Hadoop, okay, the MapReduce is going to receive source data and try to analyze it, okay? When you receive the source data, and the data is super large, okay, and Hadoop is going to first of all split the source data into smaller pieces, okay? Each of those pieces are equal in size. We call each of these split, each of these parts split, and those are called splits. Okay. Again, the splits is about runtime, splitting of your source data. In comparison, we have to compare the split concept with block. Okay, I think you already know what's a block. The difference: block is the concept you used when you talk about file storage. When we have a file, we have to save it onto HDFS. When we split the file into smaller pieces or shares, and each of these shares need to be saved into a specific location of your HDFS, and to better manage your storage space, we divide those storage space into blocks. Each block is the same thing, is an equally sized physical space. And we can fill each space with a part of the file contents. My file will be split into different parts. Each part ideally will be the similar size, will be same size to your block, so they can be put into blocks. One part put into one block. That's how we stored your big file into using the block concept. Again, the splits is a similar idea. Split only happens when you run your MapReduce application. But my MapReduce runs instantly. The huge file will be uploaded and come into your MapReduce application. When I touch the Hadoop, the source data will be instantly divided into splits. Okay, that's the difference. Hadoop creates one task, one map task for each split. Okay, pretty intuitive. A good split size tends to be the size of HDFS, 128 megabytes by default. Data locality, that's the last concept of here. Data locality, this figure explains it all. We have three scenarios, okay? Scenario A, okay, each white box in this figure represents one node. So here, scenario A, your map task and your data source are located in one node. That means your computing and your data are actually in the same place. That's the closest distance we can get. And this is the best scenario we can get. Again, your HDFS is gonna try, your Hadoop try to schedule the map task onto the computer that exactly having the data. If that's allowed, then you have a scenario A, the best case. And sometimes this cannot happen because when Hadoop try to schedule the map task onto this computer could be really busy or out of resources to run the map task, then scenario A failed. Then we try scenario B. Now Hadoop will try scenario B, which means not on same PC, same node, but they're still very close. So in scenario B, the computation, the map task, and the data sources are located in different PC, but still in the same rack. Different PC, but they're in the same rack, which means indicates the bigger green box. Okay, so scenario B is not as good as A, but it's better than C. Scenario C is the least favorable case. That means your computation is located in the computers in one rack, but your data source has to be accessed from computers located in another rack. Okay, so to rank it in terms of a favorable, A is better than B, B is better than C. Okay. Last part, read figure 2.3, 2.4 to understand MapReduce data flows for these 4 points. Point 1 and point 2 is about output of mapper and reducer tasks. So let's go to look at those figures right here. So figure 2 to 3. Here in this case, I have 3 mapper tasks and 1 reducer task. Okay. Point 1 and point 2 in the study guide is about where the output is going to be located, okay, for mapper and reducer task. For the mapper task, each of the mapper tasks is going to save its output locally. Means if mapper 1 is running on this node and the output of this mapper is going to be saved to the same node. Okay. In contrast, a reducer task, when the reducer finishes, the output of reducer will be saved to HDFS, which is the not local file system. That's the difference. Okay, point 3. Reducer needs the complete data from all mappers. Here's one reducer. The reducer is waiting for the output of 3 mappers. So the reducer will not start to run until it receives all the output from the 3 mappers. Okay? So that's what it says, point 3. Point 4, the multiple reducer case. Each reducer needs the complete data for all mappers. So let's go to figure 2 to 4. In this case, we have 2 reducers. Why? Because sometimes you may set multiple reducers for different purpose, but they're all rely on the same mapper task. Okay. For example, reducer 1 could run for the purpose to output maximum temperature, but reducer 2 is trying to run the maximum temperature for each state in the US. Okay, they're different purpose, but they are rely on the same mapper output. Okay. The point 4 here says if you have multiple reducer, each one of the reducer are gonna behave the same way. They are all gonna require all output from each mapper. Okay. So in this case, the map gonna create multiple copies of the output and send it to each of this reducer. Okay, this is the finish of chapter 2.